Next, we will discuss about the intermolecular forces. Between covalent compounds, there are some interactions of the molecules. We can say that the interactions are quite weak in comparison to the covalent bond itself. So, in principle, we can divide the molecules into three groups. The first one is the non-polar one, and then the polar one, and finally the polar one with H that is bound to either oxygen, fluor, or nitrogen. In principle, for non-polar compounds and all of covalent compounds in general, the main intermolecular forces is what we call the van der Waals interaction, or if it's only a non-polar compound, we can also say the interaction to be what we call the London dispersion force. Another name for this would be the induced dipole interaction. Induced dipole, transient dipole interaction. This is the weakest among the forces between molecules. For polar compounds, apart from these interactions, we also have what we call dipole-dipole interaction. So if we have HCl, we know that the H will be partial positive and Cl will be partial negative. So between Cl with the other H, there will be a Coulombic interaction, and this is what we call the dipole-dipole interaction. And this will be stronger than the van der Waals interaction. Now, specifically for polar compounds that has a hydrogen atom bound to either oxygen or fluor or nitrogen, like in H2O, HF, and NH3 or ammonia, we have what we call the hydrogen bonding. And this is the strongest intermolecular forces for covalent compound. Suppose we have water, so it should look like this with two lone pair. Then between the oxygen of one hydrogen H2O, the oxygen will interact with the H that binds a different molecule of H2O. And this interaction is what we call the hydrogen bonding. The strength for this particular interaction goes the weakest for the van der Waals interaction or London dispersion force. And then the medium one would be the dipole-dipole interaction, so medium strength. And the strongest one would be the hydrogen bonding. And these intermolecular forces play a role in determining the properties of the molecules. We can see this from the boiling point for liquid system or aqueous system. And also we can see this effect of intermolecular forces in the vapor pressure. So vapor pressure is if we have a system of liquid, and normally between the liquid there is an equilibrium with gas phase. And this will correlate directly with the boiling point, where the boiling point is the temperature in which the equilibrium is reached. Now, if the interactions are very strong between the molecules in the liquid system, it will be very difficult to become gas. Therefore, the pressure of the gas on top of the liquid will be low, as most of the compounds are still in the liquid phase. Therefore, for boiling points, it also goes from the weakest to the strongest. The one with the hydrogen bond will possess the highest TB or boiling point. On the other hand, for vapor pressure, it goes the opposite, because compounds with hydrogen bond interact strongly in the liquid phase, it is difficult for it to become gas, and therefore there is not much gas that will be formed from such molecule, and therefore the vapor pressure or the pressure of the gas will be low. So actually the one with the highest vapor pressure would actually be the one with weakest interactions, which is the nonpolar one. While water or H2O molecule is undoubtedly is the most common example for hydrogen bonded molecule, we have to be careful in examining other molecules. For instance, take a look at this molecule CH3F. We can ask whether this molecule has a hydrogen bond. Now, just because you see H and you see F does not mean in any way that this would have a hydrogen bond. You have to draw the structure. So CH3F is basically methane, in which one hydrogen is being substituted by F. So the structure would be C, H, 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 and F. So in this case, it does not have any hydrogen bond. Because if you see for water or for HF, the H itself has to be bound to either F, O, or N. In this case, you can see that the H is actually bound to carbon. There is no H that binds the F. So for example like this does not have any hydrogen bond. However, as you can see, the molecule is not symmetrical, unlike the methane. We can say that this is a polar compound. Therefore, the dominant interaction would be the dipole-dipole interaction, which is the medium strength, in comparison to HF and H2O that have the actual hydrogen bond where the H is bound to F, H is bound to O. Another example would be if the H is bound to N. If H is bound to carbon like this, then this is not a molecule with hydrogen bond.